This is and some live coding. So if you wanted to do it with me, the complete answers are on the demo complete branch, or you can just clone the Chainhook demo without the answers filled in. So if anyone wants to code with me, you're welcome to. This is a Rust project. I'll bring this back up later, but just while we're waiting. Yeah, I didn't know there was a live stream, but people are welcome to follow on the live stream. Clone this repo, and when I do the live coding, or you can, get the completed answers there, and I'll explain what we're making in just a minute. Cool. Well, we can get started. We are going to be building a compact Bitcoin index today, like right here, right now. A little index to go over what we're talking about. I'll give an intro to this tool that we've made called Chainhook. Then we'll get to building. I'm going to discuss the Hiro platform a little, which I think can be really helpful for people here at the hackathon if you're building something. And I'll have some time for questions. So first, hi, I'm Micaiah. That's a picture of me so that you know I'm actually me. I love making developer tools. Even when I wasn't making developer tools, whatever job I got to, I ended up making tools to make people's jobs easier. It's just, I love doing it. And then I got the chance to join the Truffle team on the EVM side, and I was working on Ganache, which in the Ethereum world gets you a little bit of street cred, and I think it mainly gets you an eye roll in the Bitcoin world to say that I worked on Ganache. And now I'm at Hiro. I'm working on Chainhook and Clarinet. Hiro, we make dev tools for the Stacks blockchain, but also stuff for Bitcoin. So that's me. So I want to talk about just a problem that we wanted to solve with Bitcoin indexers. If you want to index the chain, that's great. It's just going to take a long time, and you're not going to use most of the data, right? Like, hopefully we're not all building a Bitcoin block explorer. It's just too many block explorers. So you probably don't need all that data. So maintaining index, it's difficult to set up. It's time consuming to actually do the index. It's expensive to store all the data. And it's overkill for most people's needs. And creating index is all or nothing. Like, you have the whole thing, most of which you don't use, or you don't have an index at all. We made a tool called Chainhook. It lets you index the data that you want, no more, no less. It's super easy to set up, easy enough that we're going to do it here today in just a few minutes. And so the way that it works is you have these if this, then that predicates. It's just a JSON object that you can put. So like looking at this one, we're going to get all data from start block 840.864 to, that end block. I think I maybe swapped those, but, start block should be less than end block, obviously. And then we have some if this condition. If our input has a transaction ID, we want to get all of those inputs, or I'll go over the other predicate types that we have. So there's a lot of filtering that you can do. And then that condition. What do you want to do? You can save that data directly to a file, or you can send that data to some URL. And so you can take that payload and handle it however you want. And in doing this, Chainhook is reorg aware. So if there's a reorg that happens, Chainhook will notify you of all of the new blocks that are being applied and all of the past blocks that need to be rolled back that relate to your predicate. So again, you're not getting these rollbacks that don't affect your data set. You're only notified about what you actually care about. And so on our docs site there, docs.hero.so/chainhook, there's a bunch of different predicate types that are specific to Bitcoin. You can also use Chainhook to index the Stacks blockchain. This is just a few of them, so there's more there, but you can filter on the op return. So you can get all transactions where the op return starts with some data, or ends with some data, or contains some exact data. You can match the transaction outputs by script type. So there's P2, PKH, there, all the different script types and the actual contents of it. A really powerful one is wallet descriptors. So with this, you can say, I want you can set up a predicate that says, I want all addresses that could ever be generated for this public key with this script type. So like, you pretty much like if I want to see every transaction that my public key could ever make, you can set up a predicate and always be notified about that. And then also we have stuff for ordinals. So there's ordinals protocol filtering that you can do. That powers a tool that we make called ordhook. And so there's 3 ways that you can use it. We're going to go over the Chainhook SDK today. So this is a Rust project. We export a lot of functions that make it really easy to make this index. And so you can be notified about all new blocks and filter it and to create your data set. There's the Chainhook CLI. This allows you to self-host. You can use it to scan all historic data. So I can create a predicate that goes from Genesis, to chain tip if you want. And it has a API to register new predicate. So it's like, oh, I want this data too. You can just send a request to this, register a new predicate that extracts this other data set that you want and create custom data sets on the fly. And then there's a Hiro platform. We'll talk more about that later. But we run a Bitcoin node and we have a Chainhook service running. So you can just use our Hiro platform to quickly get data. It's really helpful for just like you want to, get a small data set or you're just curious about something on chain. You can just create predicates and get the data immediately. It's really sweet. And so now we will get to building. I'm going to leave this up for just a minute again. If anyone is cloning this repo. And if you do clone the repo, it's going to look something like this. So just to go over what we're going to make here, this app that I've made, our main function is not filled in, but I have built here in Rust, there's just a front end that will display blocks from some database, right? And we have an empty database. We don't have any data. So I'm going to build something that will take a predicate, scan it against a Bitcoin network. I'm going to have a reg test network. So we can build a predicate. We can build something that uses Chainhook to take data from the reg test chain and fill in it's going to be a really simple database. It's just going to be in-memory store of like block height to block data. But that's the cool thing about Chainhook. You can make a really naive database like that, or you can do anything with it. You get a new block, you can choose to handle it however you want, store it with whatever mechanism you want. So we're just going to do an in-memory store. It's going to be really simple. And then we'll have a fun example using it. So here we go. First thing we're going to do is we've got a start Bitcoin event observer. So this function starts an event observer for all Bitcoin blocks. So we've got to feed it a little bit of stuff. We've got a logger that we need. So this context here, we export some helpers that just lets you set up the level. Do you want log level or debug log level, or do you want to trace log level? So you can set all of that up. Let me make sure I'm getting this right. Oh. Ooh, that's a great question. Does anyone know the shortcut for that? Command plus plus. There we go. Is that good? Yep. Yes. How's that? Cool. All right, and I'm going to take my notes and make them closer to me. Cool. Okay, so we're going to set up our logger. And, well, this is the context for our logger and our actual logger. Cool. So we've got that context variable provided. This is an async function, so we're going to await it. There's some stuff here that we don't actually need, so I'm just going to pass in none. Some advanced use cases of Chainhook that we don't need to go over here today. And then these observer commands, TX and RX, this lets you kind of interact with Chainhook in some cool ways that we don't need to go over, but it's just a channel to send data. So I'm going to define that here. Cool. Oh. And then the last thing is, is this just util? Cool. Oh, let me check my answers. Sweet. So the last thing is our actual config of what is the predicate that we're going to be observing, or like where we have to define the Bitcoin network that we're going to listen to and all of that. So config is of type event observer config. Oh, I guess just to go over some higher level what we're actually using here, our SDK it's just this. So if you have this import on a Rust project, you get all these helpers and all these types to configure Chainhook and to start getting data out of the chain. We're using a beta version because I introduced some new features for this that will get merged soon. But yes, yep, at Hiro. So we'll fill in a couple of fields here. By a couple, I mean quite a few, but it won't take too long. So part of this, because Chainhook can be used for stacks or Bitcoin. Some of this is data that's not relevant to Bitcoin. We'll have another PR that we're working on just to hide some of that stuff behind a feature. So if you're just using this for Bitcoin, you don't need to define all the stack stuff. So a lot of this, we're like, this is only really relevant for if you're using stacks. This is only relevant if you're using stacks, so we don't need it. So we need to be able to get data from a Bitcoin node. So we need to provide the RPC username, which I have as reg test. This is a string. Bitcoin RPC password. I set it to test1235 to keep the hackers on their toes. And RPC URL. It's at 8332. Yep. Okay, and then this is a string. Bitcoin block signaling. What this means is, the Stacks chain, it relies on Bitcoin blocks, so it's notified of all Bitcoin blocks. If you're running a Stacks node, you don't have to get that data directly from the Bitcoin chain if you don't want to. You can have the Stacks network forward you all the Bitcoin blocks. Here, we're not relying on Stacks, so instead, we'll say Bitcoin block signaling. We're going to use Bitcoin node 0MQ interface and provide the port that the ZMQ interface will be sending blocks from. Cool. Some more stuff that we don't really need here. So no logs. Oh wait, maybe this is a false. We don't need to have a cache. Oop. There's Prometheus monitoring setup. If you're running this as a service, you can kind of get some insight into what's going on there. Oh, this is a string. Cool. And then we have to define the Bitcoin network. There's mainnet reg testnet that you can do. So Bitcoin network. And Stacks network. We're not using this, but it's currently required to define it. Again, we're working on a feature just to get rid of this, so you don't have to if you're just using Bitcoin. So it doesn't matter what we set that one to. Cool. So this is a string. What have we done? We have configured Chainhook to get notified of new blocks from our Bitcoin network or Bitcoin D nodes ZMQ interface. So when you configure the reg test network, you set up to notify anyone listening on port 18543 of new blocks. Chainhook's going to ingest that. And then when it needs to download additional block data, we provided the Bitcoin RPC URL, and that's what Chainhook will use. So that's pretty much what we've done here. And then finally, it's just the actual chainhooks that we want to load here. So this is like the predicates that we're going to create to decide what data do we want to get from the chain. So what we're going to do is, rather than finding some other way to pass it in, we have this JSON file of a predicate. We're just going to read that. I'm not going to handle errors here. Do it the fast and dirty way. So we can deserialize that file to a type. We're going to use 30 JSON. We're going to pass in that string. We just read that file. I think there's some people who've never used Rust, so this is a quick insight into what some of it looks like. Okay, so now we've got this specification here, this hook spec. So let me just show what the type looks like here. You can provide name of a predicate, a UUID, and then you can have multiple networks mapped to a specification where we have like the start block that we're going to filter, the end block, the number of blocks we want, whether you want to include the proof or the inputs or the outputs of the transaction or the witness data and the actual filtering that we're doing. And so here we're just let me type it first. I'm bad at typing and talking. So we're going to define what network we want our predicate to be evaluated against here, because we can use the same predicate for multiple networks. So we can create one predicate and use that same thing to evaluate against reg test, testnet, and mainnet. And we're going to enable it. And then one more thing is the actual Chainhook config. So we can register many chainhooks and have them all be evaluated for every single block. We're just going to do this one. So chainhook config dot register specification and our Bitcoin chainhook. Cool. So here we've got everything that we need to, like, when this starts, we're going to download whatever predicate we put here. We're going to configure chainhook. Oh, what is this type? Sorry about that. This is a Boolean. Let's get all these errors fixed before we continue on. Cool. So yeah, we're going to download this predicate file. This is going to define what's the data that we actually want out of the chain. And then we configure Chainhook to listen to the Bitcoin node, download the data that it needs, and be notified of every new block, and then we're going to actually start that event observer. So anytime a new block is mined on the network, it's going to be sent to Chainhook, and then Chainhook is going to evaluate that block data against our predicates that we've created. And if we have a positive match, so if we have a transaction that has an input with this transaction ID, then we're going to do whatever is in this then that condition. So we're going to post to that this localhost 8545/chainhook. So that's going to be our last step here, is just we've got a server that's hosting a front end. It's got some GraphQL endpoints so we can make queries to the database. So now when that predicate is evaluated and Chainhook posts the data that matches to 8545/chainhook, we need to handle it. So we're just going to store it in a database. So I'm going to go to our Chainhook endpoint here. So we have configured that predicate whenever there's a match to send data to this endpoint. And so now we're just going to store it. I'm going to copy this code just so you all don't have to watch me type a lot more code. No, we haven't done that yet. So all we're doing here is we're getting this payload that is going to be that's sent from Chainhook. We'll look at that. So it's going to give you some number of blocks to apply. So if one block is mined, we'll have one block to apply. But if there's a reorg and 5 blocks are rolled back and we have 6 blocks to apply on top of that, we're going to be notified of all of those. So Chainhook handles all the reorgs. We're going to get the Chainhook that this applies to. We're only registering 1 right now. But if you wanted to create, 5 predicates that give you different types of data and you want to store those in different databases, you're notified of, okay, this is the predicate that led to this evaluation and to you getting notified of these blocks. And so you can choose to handle that data however you want. So here what we're doing, we're getting that payload, we're deserializing it to that type, and then we're going to loop over all of the blocks to roll back, and we're going to remove it from our in-memory store. And if we get a new block to apply, we're just going to insert it. So we've got a pretty much a big JSON object map that is the block height, the index of the block identifier, and a string serialized version of the block. So now we've got this in-memory database that has block data and by block height. And so now we just need to start this service. Let me, again, copy the answers just to make things a little easier for y'all. I also introduced a multi-threaded component here that I'll explain. So we have one thread that's actually running Chainhook to listen for the data, and now we've got another thread that is actually running our server. So that's why I moved that Chainhook function into this thread. Let me import some stuff. Cool. Server. There we go. So, sorry about that. That's all of our code. We've got Chainhook running that is going to filter all the data of new blocks, and we've got a server that's going to display it. And now we can get into the actual example. I'm going to, I don't know if people have seen BitVM, and SuperTestNet has made this tic-tac-toe game. So pretty much every move in the tic-tac-toe game is sent on chain. And so if you are observing the chain and you're like, I want to know when a tic-tac-toe game is happening, or I want to know when the next move happens, how do you get just that data? We're going to be able to do that with Chainhook. So it's a really cool thing that he's put together. You can go to SuperTestNet/BitVM Workshop on GitHub to see that. So let's do it. This is what his tic-tac-toe game looks like. And I've got some, I'm gonna be doing this all on a reg test network. I'll try and explain exactly what I'm doing as I go. But so first we'll start with clicking play. It wants you to send money to this address and enter the transaction ID. So I've got some helpers, first of all, just to get us, funded accounts on the RegTest network. So cool. I'm going to set up our wallet with wallet name. So this script is generating a wallet, mining some blocks to fund it. So we have a source of monies to send to that address. And then I'm going to just define some more variables here so you don't have to look at a bunch of ugly keys. And so we'll need the UTXO transaction ID that's going to be funding this. So I'll copy that from here. Cool. And so now we need to transfer money to this address. I have a script for that. Transfer, need to pass in. Let me make sure I get all the stuff I need to pass in. So this is saying transfer the money to that address using this wallet name, this from address. The funds are going to come from this UTXO, and it's going to be vout number 0. So we make that transfer, and now we have a transaction ID. So that's what SuperTestNet's tic-tac-toe game wants. Before we continue on that front, I'm going to now actually create our predicate. So I'll explain what this predicate's going to do. I've taken that transaction ID and I've put it here. And so we are going to look at all transactions that come in on this network on any block. We are going to look at the transaction inputs, and we're going to see if any of those transaction inputs match this transaction ID. And then I have follow inputs set to true. So what that's going to do is now that transaction, if it is used on any subsequent inputs, we will get results from that. And so it's going to keep propagating. So pretty much what this means is we have some starting transaction, and we can now get notified of any subsequent transaction that at some point in its ancestry got funds from this initial funding transaction. And so something like a bit VM series of transactions that goes back and forth, for example, the tic-tac-toe game, you have to respond in a total, like in 4 Bitcoin blocks or something. And tic-tac-toe game has 9 squares. So 9 times 5, there's 45 potential blocks. So we could say start at block 100 or whatever to 145. We know that's all of the data that we care about. And we don't want to be notified, if a block goes by and there are no transactions that are part of this game, we don't care about it. But with this, we are going to get notified of every single transaction that is part of this tic-tac-toe game. So we've got the predicate created and cargo run. So listening for Chainhook payloads, the server is listening for them here, and we can view it here. We don't have any data yet. We haven't mined any blocks. And so let's continue on our tic-tac-toe game, send money to this address and enter the transaction ID. Okay. The vout, let's look at the funding transaction. So it was vout number 1 that went there, and we sent 10 million sats. Now it wants us to place an X and broadcast the transaction. So step 2 of the game is broadcast this transaction to start it. I've got a script that's just going to broadcast that transaction. Did I do something wrong there? Oh, I called it wallet address, but it is. Cool. So we have broadcasted that transaction that BitVM has generated as part of this tic-tac-toe game, and we can mine the block. This is going to mine the block on our network. We've mined that block. And if we look at our Chainhook demo, we've parsed that data and we've recognized a match that this transaction uses that other transaction input. So we want to match on that block. And if I go and I mine some other block, none of this is going to generate a payload. So 3 blocks go by. No one has made a move for this tic-tac-toe game. Chainhook ignores that, filters that data out. So you can create the store of exactly the data that you want. So let's play tic-tac-toe for a bit. We'll just follow these instructions. Enter the pre-image, or the move pre-image. Paste that there. It says broadcast this transaction hex. So I'm going to do my send a decode script with a much bigger payload. And I'm going to mine a block. And then it says place an O. Got another thing to broadcast. And mine a block. And it says enter the accept pre-image. So if you want to know about what the heck's going on with this BitVM game and how it works, SuperTestNet has a pretty cool video explaining it here on the repo. But if we just follow those instructions, enter the transaction data, broadcast it, mine the block. Here, Chainhook is picking up the data. It's filtering out exactly the data that you want, and it's ignoring everything else. So now we have an in-memory store of Bitcoin data that is just what we care about, that we have defined with this this predicate here. And so if we want more data, different types of data, we can just change the conditions of this predicate. If we want to, if you've got a regular index that's running and there's a reorg, it's going to change that database out from under you, right? This, you're notified of each block that's rolled back. So if I want to notify a user that the transaction they sent is, no longer part of the canonical chain, we can do that because we are notified of every single rollback. We're notified of every single block that has data that we care about. Cool. So that's the demo. I would, this is a specific use case with BitVM and my reg test that's set up. But with this, where is it? With this code that we set up, you can register any type of predicate you want, and you can build whatever database you want. So if anyone uses this, I would love to help, answer any questions or get stuff set up. But I wanted to talk about one more thing, and that is the Hiro platform. So there's a Hiro hosted Chainhook node. We're running our own Bitcoin nodes. This is super helpful for just really quickly getting data out of the chain. Platform.hiro.so. You don't have to have a synced Bitcoin node. You just go here, Chainhooks tab, create a Chainhook, and test Bitcoin. I can choose the chain that I want. I want Bitcoin. I want testnet, mainnet, whatever you want. I'll do testnet. I want all transactions where the output, the op return starts with anything. So I want all of it, but you can filter this however you want. And I'll go to webhook.site just so we have a place to see the data going. If the Wi-Fi will let me, here we go. So I give it an endpoint to send this data to. I'm going to end it at the current chain tip and just get a few blocks here. 2604589. Cool. I'll get 9 blocks. I'm going to include the inputs and outputs and witness data. Create the Chainhook, and there we go. It's running. And we see payloads getting sent here. So I've just gotten specific data that I want out of the chain. You can do it mainnet or testnet. You don't have to have a node synced, especially something like a hackathon. It's so easy to get the data you want. So hopefully that's really useful to you all. That's all I've got. Any questions? What's up? Yes. Yeah. Wallet descriptors we can do. Yep. Yeah. Yes. Yeah. He asked if we can do this by descriptors, Taproot wallet descriptors. Yes, you can do that. And we've got this indexing engine, new predicate types. It's a simple PR. Like if there are ever ideas of like, it would be cool to be able to get this type of data off the chain. We're open source. We'd love to have PRs or just issues. Yeah, we'd love to hear it. Any other questions? Not yet. It is something that we've been talking about though. So this does power reorg-proof. I don't know if you've used reorg-proof. So this is what's running underneath. So we do have ordinal support, but not specifically for runes at this point. Yeah, it might be pretty simple. I haven't started looking into it much, but oh, cool. Yeah, the guy who makes reorg-proof, Ludo, he's going to be here soon, so it'd be cool to talk about that after. Sweet. Any other questions? Sweet. If you end up using this for the hackathon or anything, please reach out. I would love to help. So thank you all very much.